Right now we will do the solution for the numericals number 40, obviously from the principle of physics, Resnick and Halliday. So what are the problem is given, you are driving towards a traffic signal when it turns yellow. So let's make the solution like this. What the data are given, the speed limit of the vehicle V0, let it is given as V0 is equal to 55 kilometer per hour. So for our calculation we will transfer into this data to meter per second, obviously. So if we make a calculation, so it will be like this. It will be like this. That's why I'm making a calculation. It will make calculations like this. So it will be 55 into 4. So it will be like 15.28 meter per second. So this will be, so the reaction time, so the reaction time here is given t is equal to 0.75 second, and the distance also, let the distance be t1 is equal to what we have got, v0 t. What is v0 here? Got 15.28 and time is 0.75. So far, so by multiplication we'll get what I'm making a calculations, it will be 11.46. so this is the distance, it is given in the meter. Again the distance travel during the braking, again what we got again, so we have written another data, that is a is equal to, here it is a deceleration, as it is going deceleration, so we will make it the minus 5.18 meter per second square. As it deaccelerates, so we made a negative minus 5.18. So again the distance traveled during the braking, so from the problem we have to write again the distance, traveled during the braking, that will be, let it is v1, so v1 square we have learned previously also, v0 square plus 2a d2. Therefore this will be 0 because while distance travel the braking, and this will be 15.28 whole square plus 2, what we got, 2 is equal to minus 5.18 into d2. Therefore d2 is equal to what we got, 15.28 whole square, so it will be minus 2 into minus 5.18. Again if we make the calculation, we are using the calculator, so it will be 22.53 meter. So the total distance reaction, so the total distance from reaction from reaction to complete the braking is obviously it will be d1 plus d2, because we started from, actually if we draw a picture, so it will be like this. Here the signals are there, and if you see braking, so d1 and d2 will be the total distance. So d1 and here the signals are there, the zebra crossing. So if this distance will be what we previously d1 plus d2, this will be d1 plus d2, this will be, so it will be better to understand. So now braking d1 d2 will be 11.46 plus 12 to 22.53. So these are, it will be 33.99 is equal to 34 meter. So hence it can be said, it can be said that the driver can stop within time. Again, if the driver continues with v0, as we previously know, the car would enter the intersection in time t will be what? So we have previously learned it, what it is, 30, right now it is given in 40 meters, so it will be 40 meter by 15.28, as because of in the given, it is in the A, from this A part, you can say this 40 meter, the A, it will be 2.6 obviously lesser than what we got, 2.8 second, 2.6 seconds. So it will obviously here 2.8 seconds is given, so we are in the 2.6 second obviously, so it is acceptable. So it is acceptable means it would have crossed the signal intersection. Now B, we are turning the pages. Now B part will be, part B. In this case, total distance to stop the car, that 34 meter means is greater than the distance to the intersection. 32 meter, we have previously learned it, means the intersection means cannot stop but in front of the car, but it means it cannot stop in front of the car, will be few meter ahead of intersection. So T will be 32 meter, 15.28 meter a second. What we got is 2.1 second is too long tenure. So neither the situation neither the situation neither of the situation acceptable as given in the problem. Thank you. Let's check it and make pause to understand all the numericals all the time.